Okay, welcome physics. I wanted to go over some information since you've done a few activities on the life cycle of stars. So in our simulation that we did a couple weeks ago, you would have seen that stars actually have a cycle that they go through. So stars are born, they have different stages of their life, and they die. So it's really important to understand these connections and relationships between mass and time when we're talking about a star, and then also the two forces that are at play with a star. Okay. So when we talk about these two forces, we have gravity. Okay. So anything that has mass is subject to the force of gravity. So it's going to push in. Okay, hopefully you can see that okay. And then the fusion force, because we have nuclear fusion going on inside of the core of a star, okay, we have a force that's pushing it out. So whenever we have a force, we have an equal and opposite force, right? So Newton said that anytime you have a force, you're going to have an equal and opposite force. And if those two forces, so if these two forces, gravity and fusion, force are equal, or if they're in equilibrium, then that means that the star is not changing. Okay, so like in a main sequence star, like our sun. Okay, so main sequence star, these two forces are at equilibrium. Okay, so we just have a boring main sequence star. Okay, so that means that the gravitational force pushing in all around is at equilibrium with the force that is pushing out in the opposite direction. Okay, so equal. So when you're looking at your activity forces within a star, okay, from this week, you're going to want to think about these two forces and what they're doing, and how by observing what the star is doing, we can figure out what's happening with the force. Okay, so main sequence star, like our sun, we have two forces, gravity, fusion force, and they're equal. When we have a nebula, okay, this is what I call a baby star. Okay, so it's a star as it's being formed or as it's being born. Okay, so we still have those two forces, but the fusion force here inside of the star pushing out is weaker, okay, not as strong, as the force pushing in, the gravitational force. You can see my arrows here going in. They are stronger. Okay, so this is not equal. Gravity is stronger. So gravity is greater than fusion. Okay? And that is why the nebula, as you see in the video that hopefully you watched linked with the assignment, it shows star formation. It shows this gas, hydrogen gas and dust swirling around itself, and then slowly condensing and coming together. Okay, so that's a nebula. That's how a star is formed. Once it goes through the nebula stage, it's going to become a main sequence star. So our stars, a lot of our stars will start out in our main sequence. You would have seen that from the Star in a Box lab. Okay, simulation. We looked at what happens to the stars and then what happens to mass as we change time. Okay, so main sequence and nebula. So we've got our first stage, our second stage. Okay, now depending on the mass of the star, low mass, high mass, or very high mass, you're going to have different life cycles. Okay, so the next stage depends on mass. Okay, depends on the mass of the star. So for where it goes next, nebula to main sequence to, it depends. Okay. some examples of the stars that you would have seen include a red giant or a blue giant. We're going to talk about the red giant stage. So, see if I can draw this on here. Okay, so if I have a red giant, this means that we have a small main sequence star that has turned into a red giant. Okay, guess what? Giant means big. So that means that this star is expanding. Okay, and we know that we have two forces at play. We have two forces, right? So here's my red giant. Okay. So we have two forces. We have the force pushing out. What's that called? Fusion force. We have the force pushing in. What's that called? Gravitational force. Okay. So if I have an expanding star, it's getting bigger, it's growing, okay, that means that when we think about the force, okay, the force pushing in to push it together is weaker than the force pushing out to pull it apart. So fusion force is greater than gravitational force. Okay? And I can draw that with my arrow, right? I might have a thicker arrow, okay? And a thinner arrow. You could draw a larger arrow, a smaller arrow, okay? However you'd like to depict that is fine. So if a star is expanding, that means that the fusion force has to be greater than the gravitational force. It's overtaking it. It's not at equilibrium, okay? Then, depending on the mass of the star, this paper, depending on the mass of the star, you're going to see a different stage. So most stars will go through the red giant phase, they're expanding, and then they run out of fuel. Okay, so towards the end of their life cycle, you might see the stage of a white dwarf. It's a white dwarf. Okay, so this is smaller than the main sequence. Okay, I'm going to go with blue this time. Okay, so a white dwarf is smaller than any of the previous stages. And we still have two forces. Okay, so if it's shrinking, if it's getting smaller and smaller, then that must mean that, like with the nebula, our gravitational force pushing in is greater than the fusion force pushing out. Okay. Okay. So other types of kind of tied in with the life cycle, not quite considered a part of the life of a star, would be a black hole and a supernova. Okay, so supernova is when you have a very high mass star and it runs out of fuel, and the fusion force is so strong that it explodes into the universe. Okay, it just completely explodes. It spews its elements everywhere. Iron, everything from hydrogen to iron, it just spews everywhere. Okay, and then that explosion causes it to just collapse back in on itself, and that's how we get a black hole. Okay, so supernova. Okay, so it explodes. And they're super cool. Just spraying elements everywhere. Okay. And then that gravitational force just goes and squishes it back together, and we get a black hole. Okay, so we're going to learn more about those. Okay, so there you have the different life cycles of a star. This is going to help you with the forces within a star assignment. Okay, where you're going to have to draw the forced arrows and then explain in words, type out what's happening for each of those stages. All right, catch you next time.